and solution set for review chapter 10. Check your answers and pause it if you need a little bit more time. I'll go on to number 19. Number 19, this one confuses people a lot because it's a trapezoid for the base. Remember, the base is not the bottom. The base is the shape that is either across from a point if it's a pyramid, but in this case it's a prism. So you have to find the shape that is the same all the way through, or it's the same twice from base to base, either from top to bottom or from front to back. This trapezoid right in here, that is the shape that's the same here as it is in the back. And I know the drawing's a little bit off. Okay, so we have to focus on the capital B is a trapezoid. How many trapezoids are there? There are 2 of them, so we're going to multiply by 2. Okay, the trapezoid is the height times the 2 bases added together, and then you divide by 2. So the height of this trapezoid is at the right angle, that's 5. The bases of this trapezoid are these 2 across from each other. This one's 12, and this one is 8, because in that top rectangle, opposite sides are equal, so this one's 8. 12 plus 8, and then we divide by 2. Do your order of operations. Inside the parentheses, it's 20. 20 times 5 is 100. 100 divided by 2 is 50. And since there are 2 trapezoids, we multiply by 2 and we get 100. Okay, that's the bases though. That doesn't have, that's not included in the lateral part. The lateral part is all these rectangles in between the bases, the ones that wrap around the outside edges. So, let me erase this for the time being, and we will do the side pieces. First of all, we have the top. The top has a length of 8, but the width all the way around is 10, 10, and 10. It's 10 centimeters from this trapezoid to this trapezoid. So this top piece is 8 by 10. This side piece here in purple is going to be 9 by 10. It's a rectangle, but the dimensions are 9 times 10. And I'll add those all up at the end. Then we have another rectangle along the bottom. The bottom rectangle has the dimensions, the sides of 12 times 10. So we're going to have to include that rectangle in it. A rectangle of 12 times 10. And then we have the last rectangle over here on this side, and let's do that one in blue. And it has dimensions of 7 times 10. 7 times 10. So the last rectangle we need here is going to be 7 times 10. So what you need to do is find the area of each of these rectangles and then add up all the lateral parts together. So this one is 80, and there's only one of them. This one's 90, this one's 120, and this one is 70. Oops. When you add all those pieces together, I believe it will be 360. Just let me double check. 170 plus 190, 360. Now remember, when the directions say to find the lateral height, you add up all the side pieces without the bases included. So, all these side pieces together add up to 360. So the lateral area is 360. And you want to mark that as centimeters squared because it's area. My Mobi doesn't work outside of a certain area, so I have to try to do this with the mouse. Let's see if I can do it. You know what? I'm just going to type it in. 360 is the answer, and it's going to be centimeters squared. Okay, that's your answer for lateral area. But for surface area, you have to make sure that you include everything, including the bases. So it's everything all together. It's the bases, and there's 2 of them, so it's 100. And it's the side faces, the lateral pieces, which is 360. So the total is 460. 360 plus 100 centimeters squared. Whoops. All right, all the diagrams are kind of big for this one, so I don't know if I'll be able to use the Mobi for all of it, but I'll do my best. For number 20, this is a sphere, and there's 2 simple formulas that you had to, when you guys did it on that day, it was really easy. Everyone had an easy time, but I told you when it's going to be difficult is when it's all mixed in with all your other rules. So you have to have this written either in your know-it or on your cheat sheets. The surface area of a sphere is 4 pi r squared. Area is squared. The volume of a sphere is 4 pi r to the third, because volume is always cubed, and then don't forget to divide it by 3. In this particular case, the radius is what we need to know, and the radius is 6. All the way across is 12, but halfway across is 6. So we're going to do 4 times pi times 6 squared. These directions say leave answer in terms of pi. On the board, since you were doing it in a different website where pi wasn't an option, we just did it to the nearest tenth. I'm going to do it in both so that you can see it both ways. So if I'm going to do this in terms of pi, I'm just going to multiply my numbers. Exponents first. 6 squared is 36. Do 36 times 4. Get 144, and then it's times pi. That would be centimeters squared. But some of the directions said to go ahead and multiply times the pi button. You know how to do that in your calculator. It's just 144 times the pi button, and you will get 452.4 centimeters squared. For volume, it's just as easy. It's just order of operations. The only thing you have to remember is to put 6 in place of the radius. So it's 6 to the third, and then we're going to divide by 3. So the first thing I do is my exponents. 6 times 6 times 6 is 216. Now I'm going to go ahead and see if I can reduce that by 3 just to make it easier. And I can. 216 divides by 3, and you have 72. So what we really have here is 4 times 72, which comes to 288, times the pi sign. That's centimeters cubed because it's volume. But if the directions say to leave it to the terms of the nearest tenth, all you have to do is 288 times the pi button, and it's 904.8 centimeters cubed. Number 21. For the surface area, we have 3 surfaces. We have the 2 circles here on top, this circle, and this circle have to be included as part of the surface. So we have 2 circles, and the radius of each of those circles is 8. But the other thing we have is a rectangle that wraps all around, and we only have one of those. One rectangle, and we'll have to figure out the dimensions of that one. Remember what we did over and over again. We took a piece of paper and we rolled it to form the cylinder. That top part of the rectangle rolls all the way around to form the circumference of this circle. So we're going to do the circumference. That's what you get for one of the sides of your rectangle. So So the circumference is 2 times pi times r. In our case here, the radius is 8. So this side of the rectangle is 2 times pi times 8, or else it's 16 pi. That's this base, 16 pi. And the height of the rectangle is 11. So now all we have to do is figure out our dimensions. For each circle, it's pi times 8 squared, pi times radius squared. That's 64 pi. But don't forget, there are 2 of them, so you multiply by 2, and you get 128 pi. For the rectangle, it's 16 pi times 11 times 11, you get 176 pi. Okay, those are all the pieces. Now we have to look back at the formula to figure out what they wanted. For surface area, they want us to add everything together. 128 pi, that is the bases, and then there's the rectangle, 176 pi. You add them all together, and you have 304 times pi. But if you didn't want it in terms of pi, all you have to do is 304 times the pi button, and you get 955.0 basically. 0.04, and it's centimeters squared because it's surface area. For volume, you have to remember that the volume is the base area times the height. So you just have to remember what you found for the base area there. I want to get this to look right. For the base area, it's the circle, base area times height. You're not going to divide by 3 because there's not a point. It's not getting smaller and smaller and smaller. So the base area we already figured out. That is 64 pi. This one circle is 8 squared 64 times pi. So it's 64 pi times the height of the cylinder. And the height of the cylinder is 11. So we're going to fill in the capital B is 64 pi. And the height, which we're going to multiply by, is 11. So all you have to do is multiply the 64 times 11. And if you want to leave your answer in terms of pi, you just leave it that way. If you want your answer to the nearest tenth, then we'll have to use the pi button. Okay, so 64 times 11. I think that's, let's see what it is. 64 times 11 is 704 times pi. And if you want to round it to the nearest tenth, go ahead and do 704 times the pi button. All right, which is about, it's rounded to 2211.7. Sorry, I have to use the mouse for writing down this low. 2211.7. And you would call that centimeters to the third. Sorry about the writing here. And the last one, number 22. It's a cone, so you have to follow the cone formulas. And for the surface area, you have to think about your two surfaces. There's a circle here. And then there's the part that wraps or curls around the cone. So we have a base is a circle, and there's only one of them. And then the lateral part is the part that curls around. Okay, the curl part, remember we have our RL, it's pi RL. The base is a circle, and the radius of, oh, we don't know the radius. Think about it. What are you going to do when you're missing this piece? I'm going to call it R. See this right triangle right here? You're going to use the Pythagorean theorem. Across on the right angle is C. So 13 squared equals 12 squared plus R squared. So 169 equals 144 plus R squared. When you subtract that, you'll get 25 equals R squared. 169 minus 144, yep. And then when you take the square root of both sides, you get 5. So the radius is 5. So we do pi times 5 squared, or else we just call that 25 pi. For the wraparound part, the curling part here, the radius is still 5, but the L stands for the slant height or the lateral height. The one that goes up the slant, up the side, and that's 13. So that actually equals 65 pi. Now they didn't ask for lateral area, they only asked for surface area. If they asked you for the lateral area, make sure you only count this part. For the surface area, you count it 25 pi plus 65 pi, and I'm pretty sure that's 90. So the surface area is 90 pi, and if you ever want to give it to the nearest tenth, you just multiply 90 times the pi button. 282.7 meters squared. For volume, this is a time that you have to use that formula that divides by 3. Because it's getting smaller and smaller and smaller and smaller. So the volume equals base area times height divided by 3. Well, you already found the base area. That's 25 pi. So plug it in. The height for the volume fills up the inside of the cone. So the height that you want for a volume is the height that's on the inside of the cone. That's times 12. And then you divide by 3. The 12 and the 3 can reduce, and we get 100 times pi. We'll do this again. 100 times pi, and that would be meters cubed. Okay, but if they wanted it to the nearest tenth, go ahead and do 100 times pi, and you would get 314. This is my estimated sign. You get about 314 meters to the third. Okay, again, both answers are valid. 100 times pi or 314. It just totally depends upon what the directions ask for.